Let us solve problem in the concepts of physics textbook problem. First problem, listen here. Find the dimensional formula of epsilon naught. To find dimensional formula of epsilon naught, we have to take the formula which relates epsilon naught. For that, we are going to take formula is Coulomb's force. Coulomb's force formula is F is equal to force between charges. F is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by R square. Now we have to find dimension formula of epsilon naught. Since 4 pi has no dimension, so that we leave the 4 pi in this formula. Bring epsilon naught to the left side. So epsilon naught is equal to Q1 Q2 divided by F into R square. Substituting Q1 Q2 F R square, this dimension formula, we can get epsilon naught dimension formula. Now we know that current formula is charge by time, so that the charge is equal to current into time. Now by substituting dimension formula of current as I for time is capital T, so the dimension formula of charge is I into T, and dimension formula for force is M L T power minus 2, and the dimension formula of R is L. By substituting all these dimension formulas in this equation, we can get dimension formula of epsilon naught. So for charge we are substituting dimension formula I into T. For another charge also we are substituting dimension formula I into T. Divided by force dimension formula M into L into T power minus 2, and the dimension formula for R is length L power 2, since R square is there. Now see here, this M let us take to top, so that M power minus 1, and here 1 L is there, here L power 2 is there, so altogether L power 3 we are taking up, so that L power minus 3, and here T power minus 2 is there. If it goes up, T power plus 2, and here 1T and here 1T is there, altogether T power 4, and I, here one I is there and here one I is there, so I into I power 2. So dimensional formula of epsilon naught, dimensional formula of epsilon naught, we are getting M power minus 1, L power minus 3, T power 4 and I power 2. Let us solve second problem. A charge of 1 coulomb is placed at the top of your college building and another equal charge at the top of your house. Take the separation between the two charges to be 2 km. Find the force exerted by the charges on each other. Now let us write given data. What are the given means here? Two charges are equal charges. Two charges are equal charge. Q1 and Q2 is equal to each 1 coulomb. And the distance by which they are separated is or that is equal to 2 km, that you convert into meter, so 2 into 10 power 3 meter. Now we have to find force. Force is equal to 1 by the force is equal to force we have to calculate. Force exerted between them. So formula for Coulomb's force is F is equal to K into Q1 into Q2 divided by R square. This K value is known as 1 by 4 pi epsilon naught, whose value is taken as 9 into 10 power 9. Now by substituting all the values, 9 into 10 power 9 into Q1 is 1 coulomb, and Q2 also 1 coulomb, divided by R square. R is given 2 km, so that 2 into 10 power 3 whole square. Now see here, 9 into 10 power 9 in numerator is there. Denominator by squaring we are getting 4 into 10 power 6. By squaring we are getting 4 into 10 power 6. Now 10 power 9 and 10 power 6 if we cancel, we will get 10 power 3, and this 9 by 4 is 2.25. So 2.25 into 10 power 3 Newton. So in this problem, force exerted between these two charges is equal to 2.25 into 10 power 3 Newton. Let us solve third sum. At what separation should two equal charges, each 1 coulomb, be placed so that the force between them equals the weight of a 50 kg person? Let us write first one, given. Question is asked, at what separation between two charges 1 coulomb? That means distance is asked to find, or is equal to question mark. And each charge 1 coulomb. So Q1 is equal to Q2 is equal to 1 coulomb given. This force must be equal to weight of this coulomb force is equal to weight is given. Weight formula is mg. Mass of the person is given 50 kilogram. So now question, let us solve this question. Here given that this coulomb force is equal to weight of the person. Coulomb force is equal to weight of the person, W. Coulomb force is equal to weight of the person. So let us substitute weight is m into g. This coulomb force is K into Q1 into Q2 divided by R square. r square. Now we need to find r. So let us take r square is equal to k into q1 into q2 divided by g. Now we are going to substitute the values of k, q1, q2, g, everything. K value is 9 into 10 power 9. Q1 is 1 and q2 is 1 divided by g value, let us take 10. G value, let us take 10. Now we need to find r, so that let us take square root. Square root we are going to take. We are going to take square root. Here one more thing, when we are bringing r square to the left side, m into g will come right side downward. In denominator it will come, so that m into g. So this m value also we need to substitute. M value is 50. So now listen here. This 50 is here 10 power 0, here 10 power 0. This 0 and this 0, this 10 power 9 if we cancel, we are getting 10 power 7. 10 power 7 we are getting. So that answer is 9 by 5 into 10 power 7. This 9 by 5 into 10 power 7. This 10 power 7 we can take as a 10 into 10 power 6. 10 power 6 if you take outside 10 power 3 in the square root of 90 divided by 5. 90 divided by 5. This 90 and 5 if we cancel, you will be getting 18. Square root of 18 is more than 4, less than 5. So that square root of 18 approximately 4.3. So we are getting 4.3 into 10 power 3 meter. So distance by which these charges are separated is 4.3 into 10 power 3 meter. Let us solve fourth problem. Two equal charges are placed at a separation of 1 meter. What should be the magnitude of the charges so that the force between them equals the weight of 50 kilogram person? Let us write first given. What are the given means? Distance by which the two charges are separated is 1 meter, and the charges how much is placed we need to calculate. So charges is equal to question mark. Two charges are equal. Here given that q1 and q2, two equal charges are given, that is taken as a q. And this Coulomb force should be equal to weight of a 50 kilogram person. That means mass of a person is given 50 kilogram. Now we are going to solve this sum. So here force between Coulomb, this Coulomb force is equal to given that weight of the person. Coulomb force formula is k into q1 into q2 by r square is equal to weight is m into g. Now this q1 is q and q2 also q, and m into g is there. This r square you take right side, so that into r square divided by k down in denominator it comes. Here q square is equal to m. M is given 50 and g is given 10 and r is given 1 meter. So 1 square divided by this k value we are substituting 9 into 10 power 9. So by simplifying this, we are getting this 500 is there in numerator, 500 is there. So 10 power 2 and 10 power 9 if we cancel, 10 power 7 we are getting. So 9 into 10 power 7 in numerator we have 5. Here q square, by taking square root we are getting what is the answer means here. But denominator 10 power 7 is there. This 10 power 7 we take 10 into 10 power 6. 10 power 6 if we take outside, so that 10 power 3 and the square root of 5 by 90. This 5 by 90 if you take square root, 5 and 90 if it denominator 1 by 18. This 1 by 18 nearly 2.3. 2.3 is nearly 0.23. 1 by 18 nearly 0.23 into 10 power minus 3. This one we are writing as 2.3 into 10 power minus 4 coulomb. So charge on each sphere is 2.3 into 10 power minus 4. Let us solve fifth problem. Find the electric force between two protons separated by distance of 1 Fermi. Let us write given data. Here given is two protons separated by, that means two protons charges are equal. The charge of the protons is 1.6 into 10 power minus 19 coulomb. And distance by which they are separated is 1 Fermi is given. 1 Fermi is known as 10 power minus 15 meter. Now we need to find electric force between the charges. The formula for electric force is equal to k into q1 q2 divided by r square. K value is 9 into 10 power 9 and q1 value is 1.6 into 10 power minus 19 and q2 value that is also proton, so that 1.6 into 10 power minus 19 divided by r square. R is Fermi. 1 Fermi is 10 power minus 15, so 10 power minus 15 whole square. Now we are going to simplify this one. So 9 into 1.6 into 1.6 into in numerator 10 power 9 is there, and 10 power minus 38 minus 19 minus 19 10 power 38, and denominator 1 10 power minus 30 is there. This 10 power minus 30 and 10 power minus 38 if we cancel, we are getting minus 8, and this 10 power 9 and 10 power minus 8 if we cancel, we will get 10. So this answer we are getting 9 into 1.6 into 1.6 into 10. This, if we multiply this all these values, we will be getting as 230 Newton. So force between two protons when they are separated by the distance 1 Fermi is 230 Newton.